This is an introduction to Fragfit. Fragfit is an interactive web service for guided modeling of missing segments such as loops or hinge regions into density maps. For this video we will use our own example. If you want to know how to find proteins and maps in general, please check out our other tutorial video. You can find a link in the description of the video. The example we use here is a subunit of the ribosome and can be downloaded from our web page. To do so, please go to the Fragfit web page. As you can see here, we have a Get Started page, which gives you a short overview of our Fragfit and a manual with more detailed information. Please consider also our FAQ, which is constantly updated. In Get Started and in the menu, you can find multiple examples. Among others, you can find the example we use in this video, which is ribosome 50S. In order to download it, you just need to click on it. Because it is a zip file, you also need to unzip it. You can then find the protein in PDB format, the map, and the best results after using Fragfit. The given README file gives you all necessary information to repeat the experiment. We will now repeat the first trial. To start a Fragfit job, you need to click on Calculation Run Job. Then the NGL viewer opens in another tab. As you can see, there's a short explanation of the NGL viewer. Please read the instructions carefully. Now we want to start our job. To do so, we have to click on New Fragfit Job. As you can see, you now have to fill in necessary information like the steam residues, the fragment sequence, or the map resolution. Information you can find, for example, in our README file. But first, we will upload the PDB and the map. Please note it is possible to also upload compressed files. As you can see, the NGL viewer shows you the protein and the map. Before we fill in our information from the README file, I want you to notice another function of Fragfit. Fragfit can remodel loops, which you might need when the loop is very flexible and the initial modeling doesn't fit well with the density. Then you can click 2 times a residue in the protein and then use the functions decrease an N-terminal or increase a C-terminal stem. As you can see, the fragment sequence is then filled in automatically. Obviously, this only works if there are residues in your model and the residues have the same chain. There is no way in Fragfit to connect a loop ID with different chain IDs. But for our example, we have all needed information, so I just fill them in now. After all informations are set, you start Fragfit by clicking Submit. Then you might have to wait a bit until the results are shown. Now you can view the results. Depending on what you want to see, you can make the map or the PDB invisible by clicking on these buttons. You can also change the coloring scheme of the loops. When viewing the results, please consider the ISO level. The ISO level makes features of the map more visible. In order to do so, you can either type in a concrete ISO level you're interested in, or you vary it with the shown bar. The best ISO level for our example is also given in the README file, so if you change it to 2.44. Notice that you can look at the different loops by clicking through the list. You can even show all loops at the same time. With Show First, you can always come back easily to the first result. In order to download a loop, you can click on the symbol or you just download all results by clicking on Download All. After a Fragfit job, please notice that you still have to minimize the side chains, and we strongly advise you to take some validation steps. For more information, please look in our manual and FAQ. Last but not least, please make sure that Fragfit is the best tool for your task. In the FAQ and the manual you can find out more about limitations of Fragfit and about alternatives. If you have further questions, please don't hesitate to write us a mail. Thank you for using Fragfit and thank you for watching.